With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
A coil having magnetic moment of 15 ampere per meter square is placed in a uniform magnetic field of 4 Tesla in the horizontal direction, and it exists in such a way that initially the axis of a coil is in the direction of the field. Now if the coil is rotated by 45 degrees and the moment of inertia of the coil is 0.5 kg meter square, then the angular speed acquired by the coil you have to calculate. So initially the coil has some magnetic moment. Let us say that the magnetic moment given is 15 ampere into meter square. Now the magnetic field in which they are passing is 4 Tesla. Next, what is happening? The coil is rotated by 45 degrees. So if the coil rotates by 45 degrees, there you get a torque. When a coil is rotated in a magnetic field, you say that the torque exists. And the torque acting due to the magnetic field, we call it as tau is equal to mb sine theta. It is the equation of torque due to the magnetic field or magnetic effect. But when the coil is rotated, there will be one more torque additional to that, an external force which is applied, and that torque we call it as tau is equal to I alpha. And alpha is the angular acceleration, I is the moment of inertia. So tau you can even write it as I into d omega by dt. Alpha is angular acceleration, so you write it in terms of angular velocity. It is I into d omega by dt. So these two torques should be equal and opposite, because these are the same torques which are acting on the same object. So both the torques should be equal. So I can write it like equating these two equations. I into d omega by dt will be equal to mb sine theta. Now in this d omega by dt, we can write it as I into d omega by d theta into d theta by dt. You just write it in terms of angular acceleration, that's it. So angular displacement, because you have theta term here, so here also we are expressing it in the theta term. Now you can just write it like theta term you can take it to one side, and omega term you will retain it to the other side, so that the equation becomes, we will write it as d theta by dt as omega, because rate of change of angular displacement is angular velocity. So I into omega into d omega by d theta is equal to mb sine theta. Now this d theta term will take it to the other side, so you'll get it as I omega d omega is equal to mb sine theta into d theta. The next thing what we do is we integrate it, because you need to get the value of omega, right? So you will integrate this equation. So integrating this equation, we'll write it as I into integral of 0 to omega into d omega is equal to m and b are constant. Magnetic moment and magnetic field is a constant for that coil. If it is rotating or if it is not rotating, the same magnetic moment and b will be there. So that we will write it outside, and it is integrated between 0 to 45 degrees, because the coil is rotated by an angle of 45 degrees. So 0 to 45 degrees. The remaining here is sine theta into d theta. Now integral of omega into d omega, you will write it as I into omega square by 2, 0 to omega is equal to mb into sine theta integral is minus cos theta, and it runs between 0 to 45 degrees. Now in this you can write it as half I omega square is equal to minus mb into cos 45 minus cos 0. And when you substitute all the values here, you get the equation as left side remains same. So here it will be minus mb into cos 45 is 1 by root 2 minus cos 0 is 1. So half I omega square will be equal to 0.29 mb is the value you get here. Now you need to find the angular speed, right? Omega you have to find it out. So omega will be equal to root of 0.29 mb into 2 divided by I. So substituting all the values over here, omega will be equal to, see you can write it as root of 2 into 0.29 into magnetic moment is 15 into magnetic field is 4 divided by I, the moment of inertia they have given it as 0.5. So omega you will get it as 8.34 radian per second. So the angular speed of the coil will be 8.34 radian per second. So you can see option C will be the right answer.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.